Okay, see what this question reads. Nitrogen dioxide, NO2, exists in equilibrium with dinitrogen tetroxide, whose formula is N2O4. Nitrogen dioxide is brown and dinitrogen tetroxide is colorless. Okay, you can see over here, this is the equation given. You can see here, this is 2 moles. And here there is no number, it means this is 1 mole. Here the 2 volumes of the gas is getting converted into 1 mole of the gas. Why? Because here 2 moles of this gas is there. It means when the forward reaction is taking place, this reaction is proceeding with decrease in volume. All right. See what the next part reads. A sample of nitrogen dioxide and dinitrogen tetroxide equilibrium was placed in a closed gas syringe. You can see the gas syringe is over here. The syringe plunger was pushed in. This increased the pressure in the gas syringe. The temperature was kept constant. State how the color of the gas in the syringe changed. Explain your answer in terms of position of the equilibrium. Okay, as we have seen in the earlier classes, if this is 2 volume and this is 1 volume, obviously this reaction has to be a reversible reaction. The forward reaction is proceeding with decrease in volume. When I'm applying increase in pressure, I'm also trying to decrease its volume. Okay. So 2 volumes is becoming 1 volume. Forward reaction is proceeding with decrease in volume. So there is increase in pressure. When you are increasing the pressure, you are also trying to reduce the volume. It means you are helping the forward reaction to take place. So that's going to shift the equilibrium towards right. Okay. So I'm going to get more amount of N2O4, which is colorless. The reddish brown color which is there of NO2, the concentration of NO2, nitrogen dioxide, is going to decrease. So the brownish color is going to become paler. It means the darkness of the mixture of gases is going to decrease. Why it is going to decrease? Because the equilibrium is going to shift towards right. More of colorless gas I'm getting. The concentration of N2O4, this is increasing because of high pressure, and the concentration of NO2 is decreasing. So therefore the color is going to become more paler because the equilibrium is shifting towards right. I'm going to write this answer down and you are going to take it down, and if you have any questions you can ask me. So this is what I have written in the answer. Forward reaction proceeds with decrease in volume. Increase in pressure will shift the equilibrium towards right. So the color of the gaseous mixture becomes more faded as more N2O4 is formed, because N2O4 is colorless, dinitrogen oxide is colorless. Therefore, more of N2O4 will be formed. Concentration of N2O4 is increasing, which is colorless, and therefore the color becomes faded or it becomes paler. See the next part of the question. A sealed tube containing nitrogen dioxide and dinitrogen tetroxide at equilibrium was cooled in an ice bath at constant pressure. Now here the pressure is kept constant, but what is done? It is cooled in the ice bath. The contents of the tube become paler. Now here also the color becomes faded away. It means the colorless part is increasing. Suggest an explanation for this observation in terms of position of the equilibrium. Now here the color is becoming paler. It means I'm getting more colorless gas. And on doing what we are getting this, it's cooled in the ice bath. It means I'm decreasing the temperature. The temperature is decreased. You can see over here, I'm getting more of N2O4, colorless gas. Why? Because here the color is becoming paler. So the equilibrium is shifting towards right. I'm getting the concentration of N2O4 is increasing. The color is becoming paler. I'm getting more of colorless gas. So the forward reaction is favored with low temperature. Now this is possible if the forward reaction is exothermic. As we have done in the previous class, for exothermic reactions, low temperatures will favor the forward reaction. And of course, the equilibrium is shifting towards right. That's why we are getting more paler color. I'm getting more of colorless gas, and the darkness of the gas is reducing. So again, I'm going to write down this answer down. You will take it down, and if you have any questions, then you can ask me. Okay, we are getting more paler color. So the concentration of N2O4, which is colorless, this increases. The equilibrium is shifting towards right. And this obviously is going to take place for exothermic reaction because we are cooling it in an ice bath. So low temperature is favoring the exothermic reaction. You can take down this answer. If you have any questions, you can ask me. Sometimes even they can give you these kind of conditions, and they will tell you what kind of reaction it is and explain in terms of equilibrium. That is, they will ask you that whether this reaction is exothermic reaction. I mean, the forward reaction is exothermic reaction or endothermic reaction. Sometimes they can ask you other way around also, that the backward reaction or reverse reaction is exothermic or endothermic. Okay. So here the forward reaction is exothermic, and if they ask you about the backward reaction or reverse reaction, then it is going to be an endothermic reaction.